Okay, so now that we've practiced writing down implications and their contrapositive, we want to see how this can be used to prove things. So now let's look at a simple proposition. We'll go back to kind of even and odd for a second, just to keep things simple. So this is proposition 6.2. So assume that n is an integer, and then we want to prove that if n squared is odd, then n is odd. Okay, so this is the proposition that we want to prove. And we can first write down the contrapositive. So the contrapositive is if n is not odd, or in other words, if n is even, then n squared is even. Okay, and you might notice right away that this is going to be easier to prove. And the reason why it's going to be easier to prove is because if you assume n squared is odd, so that's how you would prove the proposition directly. The problem is then you're going to say n squared is equal to 2k plus 1, for instance, right? And then you're going to have to take square roots of things to try to get at n. And that's not going to be a good idea, because when you start taking square roots of natural numbers, it becomes difficult to work with. But when you look at the contrapositive, now you get to say n is even, which means n is equal to 2 times k for some k. And then it's pretty simple to square it and see that it's even. So we can already see in this very simple case that although the two statements are logically equivalent, it doesn't mean that they are equivalent as far as proof techniques are concerned. And so the contrapositive is much more natural to try to prove this, right? So let's go into the proof now. So assume n is an integer, and then we will give a proof by showing the contrapositive is true. So if you're going to do a proof by contrapositive, you should point this out to the reader, that that's what you're going to do. And anyone reading mathematics should know what you're talking about. So then now we assume that n is not odd, and hence n is even. Here, I am being very explicit about this, but you could have just said that n is even if you want. So there exists a k which is in the integers, so that n is equal to 2k by, we can be very specific here if we like, by definition 2.2, but honestly, you'd be happy just to say by definition here because it's such a basic definition in mathematics. And so anytime you have an even number, it can be written as 2 times something. So then we're going to just calculate that n squared is equal to 2k squared, which is the same thing as 2 squared times k squared. And let's just write it as 2k squared, where 2k squared is also an integer. Hence, by definition 2.2, n squared is even. And so we have shown that if n is even, then n squared is even by the contrapositive. We have shown that if n squared is odd, then n is odd. Okay, good. So we're done. And this last couple sentences, I'm really being very explicit and spelling all this out really for your benefit because you're new to contrapositive, but eventually we wouldn't necessarily even write this last part. But okay, so here's a first example of how it can be easier to prove something by contrapositive. If you like, you could even try to prove this directly, but you'll find out fairly quickly that that is not so easy to do and not a good idea. But it's worth kind of playing with a little bit just to show that to yourself. In the next video, we'll see another example of proving something by contrapositive.